Today's class will discuss about the definition of friction.
Yes, sir.
Definition of friction. And then we'll discuss about the coefficient of friction.
Yes.
Okay. And then we'll go to the importance of friction.
Friction. Yes, sir.
When it will act. Okay.
Yes, sir.
Suppose generally I am having an object which is placed on a horizontal surface.
Yes, sir.
Okay, that means on this horizontal surface, it is a flat surface. It is
Yes.
a
Flat surface.
Whenever we apply a force, then what will happen? Resultant of applied force, we are having a displacement. Okay, so
Yeah.
let us consider this point. Let us consider this point.
This point, yes, sir.
As origin. This is my x-axis. This is my y-axis.
Axis.
I think
Yes.
you know xy plane.
Yes, sir. Right.
Okay, fine. So, due to this, what happens it is the body or object is displaced to here. This we are calling as displacement.
This place. Okay, sir.
Okay. According to the Newton's laws, we know that according to Newton's second law, he explained that F equal to ma. Amount of force applied is directly proportional to acceleration of the object. Right?
Yes, sir.
Okay, this is what we studied. Now we are considering a rough surface. That means we are having the surface as like this.
Yes, sir.
Like this. These can be called as irregularities.
Yes.
Okay, we can call them
Irregularities.
Okay, due to these irregularities, we can say the surface it is rough.
Yes, sir.
Here there are no irregularities. So that's why this surface we will call it smooth surface.
Yes, it's a smooth.
We call it smooth surface.
Smooth surface.
Okay, fine. Now let us consider a rough surface. Suppose this is my rough surface. Whenever an object of mass m is placed on a rough surface, this is my rough surface.
Yes, sir.
Okay. Otherwise, I will write as rough surface. On this rough surface, I am applying a force. I am applying a
force.
Okay. Due
Yes,
to this application of the force, what will happen? A force F is acting on the surface.
So, yes, sir.
A force F is acting on the object, and a small force is acting on the surface with respect to object.
M.
Okay.
Yes, sir.
Okay, fine. So with respect to this, according to Newton's third law, for every action, there will be an opposite, equal and opposite reaction. There will be a force is acted on the object.
Yes.
Due to this, the force which is applied on the object, you can call it force of reaction. I'll call it FR.
FR, yes, sir.
Due to this applied force and force of reaction, okay, there will be a relative motion of the object. There will be
a relative
motion of object with respect to surface. Right?
Yes.
With respect to
surface.
And this force of reaction can be called as friction or frictional force. Okay, na?
Yeah, sir.
So frictional force, it is opposing force which opposes the relative motion of object with respect to the surface.
Yeah, sir. Okay, sir.
Okay. This frictional force always will indicate with small letter f.
F. Yeah, sir.
So it is having an acceleration.
No, sir. It doesn't.
It moves with an
Oh,
displacement.
yeah.
With respect to displacement, we will have acceleration.
Yes, sir. We do.
That means I am having the resultant force. Since the applied force and frictional force are acting in opposite direction, right?
Yes, sir. Yes, sir.
Suppose if I'm having an object of mass m, I am applying 2 Newton towards right, and I am applying 8 Newton towards right.
Right.
So how much force is acting on this object?
So 2n plus 8 newtons. Sir.
Yeah, 2 plus 8 na.
8. Yes.
That is nothing but 10 Newton.
10.
N
Yes.
means SI unit of force. Okay.
Yes, sir.
SI unit of force, that is 10 Newton. That means if forces are acting in the same direction, we need to act. Similarly, I'm having an object of mass m.
Yes.
Okay, suppose towards right, I am having 8 Newton. And towards left, I am having 6 Newton.
So then 8 minus 6 is 8 minus 6, sir.
8 minus 6 na.
Yes.
So that means 2 Newton. With respect to 2 Newton, we'll have the object will move with an acceleration.
Yes, it does move.
Right?
Yes, sir.
Similarly, in this case, applied force and frictional force are acting in opposite direction. So
Yes.
I can write it as resultant force means applied force minus frictional force.
Yes, sir, we can.
According to Newton's second law, the resultant force is nothing but ma.
Yeah. Sir,
ma.
Sir, I didn't get that, sir.
This ma, how it is.
Oh, okay.
According to Newton's second law, he explained that suppose if we are having an object of mass, whenever a force is applied, amount of force applied on an object is directly proportional to acceleration. F is directly proportional to
acceleration.
In order to remove this proportionality, first I am keeping a constant. K equal to F by A. Right?
By A. Yeah, sir.
Now observe carefully right hand side. That is F by A. F is the force applied on the object. Right?
Yes, sir.
A is the acceleration obtained from the object.
Yes, sir.
Obtained on the object. Right?
Yes, sir.
So K defines about how much force is to be applied on the object and how much acceleration will be obtained from the object.
Right? Yes, sir.
So K defines the property of the object. The basic or fundamental property of object, it is mass now.
Yes. Sir.
That's why instead of K, we are substituting M. Okay.
Okay. Sir.
So here also, my resultant force, it is applied force minus frictional force.
Yeah, sir. Applied force.
That's why I'm writing as MA.
MA. Yeah, sir.
Okay, na? That is the basic definition. Okay?
Sir.
Okay. Now, see. Suppose I am having an object here of mass m. here I'm having the same object of mass m,
Yeah, sir.
right?
Sir.
Okay. Let us consider two surfaces. On these two surfaces, I am applying a force F. Same force is applied.
Yes.
Now I want to explain the which surface will have more frictional force, right?
Yeah, sir. I got it.
Okay. Before that, firstly, see, I am having a horizontal surface. An object of mass m is placed such that applied force F is applied on the object. Okay.
Yeah, sir.
Since it is a rough surface, we are having a frictional force.
Yeah,
Right?
sir. It's a rough surface. Yeah, sir.
Apart from these two forces, there are two other forces which also act. That is, from the center of the object, vertically downwards, will have the weight. Can I say?
Yeah, sir.
From
Yeah,
the
sir. MG.
center of the object, vertically downwards, there will be weight will act.
Wait. Yes, there will be weight. Hello, sir.
Okay, fine. Now, the object is placed in contact with the surface. See here, the object is in contact now.
Surface.
So there will be a force which will act perpendicular to the surface of contact. Surface of contact, which we are calling it as normal force or normal reaction. Normal force
Or
or
normal reaction.
okay. Normal force means the force which will act perpendicular to the surface of contact.
Yes, sir.
Okay.
Yes.
Fine. Now, see here, let us consider this is the first surface, this is the second surface. Okay. Since it is object is placed on this surface, right?
Yes, sir.
Approximately here. That means here you can see this is the curve. And here it is almost same now.
Same,
Almost
yes, sir.
that means here normal force is less. Here normal force is more.
This is
now.
more.
Okay.
Yes,
So
sir.
as the normal force is more, we'll have frictional force will be more.
Yes, sir.
So we can say that frictional force is directly proportional to normal force.
Normal force, yes.
Right?
Yes, sir.
Okay. That means on the surface, how much normal force is there, that much proportionately or accordingly, we are having the frictional force.
Yes, sir.
In order to remove this proportionality, I am keeping a constant K times N. So K
Yes.
equal to F by N.
Yes, sir. Yes, sir.
F it is the frictional
Friction.
force
Yes, sir. Friction by
acted
normal
on the
force.
object or acted by the surface.
Surface. Yes, sir.
N is the normal force acted on the object.
Yes.
Right?
Yes,
So
sir.
K defines about the property of surface. Property of surface. Or we can also say it is how much irregularity the surface is having. That is defined by K. Okay.
Yes, sir.
That's why this K can be called as coefficient. Coefficient of friction. It explains about the magnitude or value of irregularity. That can be called as coefficient of friction.
Yes, sir.
It is indicated with the letter mu. You should read as mu.
Mu. Yes.
Okay, na? Fine.
Sir.
So firstly it is, we got that formula, mu equal to F by N.
F by N. Yes, sir.
F equal to mu N. Right?
UN. Yeah, sir.
Okay, fine. Okay. Remember this formula.
F equals to mu by N.
F equal to mu N or mu
Mu.
equal to F by N.
F by N. Yeah, sir.
Okay, fine. Now, suppose on a horizontal surface, I am having an object of mass M.
Mm.
Whenever we apply a force, we are having a coefficient of friction.
Yes, sir.
Mu. Right?
Yes.
Okay. So, with respect to the coefficient of friction, we are having frictional force.
Force. Yes, sir. Frictional force.
Okay. This is the forces along horizontal direction. Right now.
Yes, sir.
Along vertical direction means we'll have from the center of object vertically downwards. We are having mg. That is nothing but weight.
Wait. Yes, sir. It told me.
Okay. Object is placed in contact. In contact with the surface now.
Yes, sir.
So there will be normal force will act.
Yes, sir. And normal force.
Okay. That means along vertical direction, object is not moving now.
Sir, I didn't understand that.
Along vertical direction, object is not in motion now.
Yeah, sir. It's not in motion.
So how much upward force is there? That much downward force is present.
Yeah, sir.
So I can write as N is equal to mg.
MG. Yeah, sir. We can.
Right now.
Yeah, sir. We.
Okay. N is equal to mg.
MG.
Suppose let us consider an example. Let us consider an example. I am having a mass 2 kg. Okay.
Yeah, sir.
I am having a coefficient of friction. Mu is equal to 0.25.
Yeah, sir. Okay, sir.
Okay. Now? Suppose here I am applying a force of 10 Newton.
Newton. Okay, sir.
10 Newton. Right? Now I need to find what will be the maximum value of frictional force.
Yes, sir.
Okay. Since by definition, I can write F equal to mu times N.
Yeah, sir. Mu times.
And here we know that normal force on an object which is placed on a horizontal surface is mg now.
MG. Yeah, sir. Weight is also.
So 0.25. Mass it is 2. G means acceleration due to gravity.
Yeah, sir. Okay.
That is approximately I can consider 10.
10. Yeah, sir. 10 Newton.
So it will be 2.5 into 2. Approximately 5 Newton.
Yes.
Right?
F equal. Yeah, sir.
Okay, fine. That means F max, maximum value of frictional force will be 5 Newton.
Yeah, so the maximum.
Okay. Suppose,
Yeah, sir.
Suppose let us consider here I applied 5 Newton.
Yeah, sir. So then.
Okay, 5 Newton. Now, see here. This is 2 kg.
5 Newton.
I applied a force. Applied force is 5 Newton. We are having a frictional force. And this one it is coefficient of friction 0.25.
Yeah, sir.
Case 1. if applied force is equal to frictional force, what will be the acceleration?
Sir,
Hmm.
so the acceleration will be 0, sir.
Yeah, very good, super. Okay. Towards right, I applied a force 5 Newton.
Then it's the same
Towards
amount.
left. So I can write F resultant is equal to capital F minus small f. That is 0. That is
Yes.
nothing but MA. Since capital F equal to small f. So acceleration is 0.
0. Yes.
Next, case 2. If capital F is greater than small f.
Yeah, sir.
Okay. That means I can say that F resultant is equal to applied force minus frictional force.
Yeah, sir.
That is, for the same object, if I am applying a force, suppose, let us consider 6 Newton.
Yeah, sir. And then
Here, we are having a frictional force. Mu is same 0.25.
25. Yeah, sir.
Frictional force means mu times m. That is mu mg.
Yeah.
0.25 into 2 into 10
Yes.
is 5 Newton. Right?
Oh, yeah, sir. I got it.
So, applied force is greater than frictional force. Now.
Frictional force. Yeah, sir.
So, due to this resultant force, we'll have acceleration of the object. Can I say?
Yeah, sir.
So, I can say that acceleration of the object equal to 6 minus 5. Frictional force 5 na?
5. Yeah, sir.
By mass means 2 na?
2. Yeah, sir. The mass.
That means 1 by 2
2.
meter per second square.
Yeah, sir.
There will be acceleration.
Yeah, sir. We do have 1 by 2 acceleration.
So, acceleration is not equal to 0.
0.
Or you can write acceleration is greater than 0.
0. Yeah, sir. Okay.
Okay, na?
Huh, sir.
Fine. Suppose the same case, the same situation, that is, we are having a horizontal surface. On this horizontal surface, I am having an 2 kg object is placed,
Okay.
having a coefficient of friction as 0.25. 0.25.
2.5.
Okay. Now, I applied a force. I applied a force 3 Newton.
3 Newton. Yeah, sir.
Here my maximum frictional force. Okay, that is mu times L.
Yeah, sir.
That is
Equals
mu
to
mg.
mu mg.
Upon substitution, we'll get as frictional force is 5 Newton.
Yes.
Right?
So why did we take 2 sets? 3?
Huh?
Oh, okay, sir. No, sir. Nothing, sir. I had.
If applied force is less than frictional force. Okay, na?
Yeah, sir.
That means on 2 kg object, I am applying a force 3 Newton.
3. Yeah, sir.
Okay.
The friction.
With 5 Newton, there is an frictional force is acting. Right?
Yes. Yeah, sir. There is.
Now come to the definition of frictional force. The force which will opposes or obstruct the relative motion of object with respect to the surface.
Yes.
Right?
Yeah, sir.
Suppose I am applying 3 Newton to move the object, but with 5 Newton, I am stopping the object now.
Yeah, sir.
Then what will be acceleration?
Sir, -2.
Oi. With 3 Newton, I am applying object. With 5 Newton, I
Sir, 2, sir.
obstructing.
Sir, 2.
No. Say suppose, let us consider. Let us consider. I am applying a force of 3 Newton,
10.
right?
Yeah, sir.
Another, in this frictional force among the 5 Newton, 3 Newton is required to stop the object, right?
Yeah, sir.
But it is having frictional force is having more than 3 now.
3. Yeah, sir. Okay.
That means amount of force required to move the object is less than amount of force to obstruct the motion.
Yeah, sir. So then it's 0, sir.
So acceleration of the object will be 0,
Yeah, sir.
right?
Yeah, sir, I got.
So in these 3 cases, I can say that, okay, by combining these 3 cases, when force is less than or equal to frictional force, acceleration will be 0,
Yeah, sir.
right?
Yeah, sir, I got.
When applied force is greater than frictional force,
Frictional force.
then we are having acceleration,
Acceleration. Yes.
right?
Yeah, sir.
Okay, fine. Now here we are having that it is maximum value. We know that F max, maximum frictional force, we got it as mu n,
Yeah, sir. Maximum.
right? That
Yes, sir.
means frictional force will have values less than or equal to mu n.
Mu. Yes, there it goes.
Anna,
Yeah, sir.
is it right?
Yeah, sir, it's right only.
Okay. Firstly,
Yes.
understand this one. Understand this one. F is less than or equal to mu n.
Yes, sir.
Okay, fine. On the same horizontal surface, I am having an object of mass m is placed. Okay.
Yes, sir.
Okay. The surface is having an coefficient of friction as mu. Okay.
Yeah, sir.
Okay, fine. Now, whenever I applied a force, with respect to the application of force, there will be a frictional force will act on the object, right?
Yeah, sir, there is frictional force.
Okay.
Sir.
Okay. What will be the direction of weight?
So the direction of weight will be the force, right? Hello, sir?
No. Weight means, okay, always acts from the center of object to the
Yes.
vertically downwards.
Yes, sir. Wait.
That is mg.
Mg, yes, sir.
There is a force which will act perpendicular to the surface of contact. That we are calling as normal force.
Normal force, yes, sir.
Okay, now?
Yes, sir.
This diagram I will draw simply. See, this is my normal force. This is my frictional force.
Frictional force, yes.
Right?
Yes, sir.
Okay. Resultant of these two, that is this one. Resultant of these two forces.
Forces is okay, sir.
That can be called as R.
R.
R can be called as contact force or resultant of frictional force and normal force.
Force, yes, sir.
Okay, now?
Yes.
The angle between contact force and normal force. Contact force and
Normal
normal force.
force.
Okay, can be called as angle of friction. Angle
Angle
of
of friction.
friction. Angle of friction.
Friction.
And this letter, it is phi. Do you know this letter?
No, sir, I didn't.
Okay, phi. Okay, na?
Yeah, sir.
This is phi.
5. Hello, sir.
I think vectors you know.
No, sir, I really don't have a clear thing with vectors, sir.
I think I cap, J cap, K cap. No, no.
No, sir.
Okay, leave it. Okay. Okay, fine. Till here, remember.
Yeah, sir.
Till here, remember. In the next class, we will see the types of friction.
Friction.
Yeah.
Okay, sir.
Types of
Yeah, sir.
friction.
Friction.
Okay.